Good morning, good afternoon, good evening, depending on when you're watching this. It's your boy, Mr. Malachi, and I thought I could make a video on transformation in functions or transformation of functions. So, what we need to first understand is how these guys look like. And what do I mean by that? Is, for example, if a graph is undergoing a translation, right? What is a translation? This is a movement, and you get different types of translation. You get a translation that goes up and down, that's a vertical translation, and you get a translation that goes. So let me first write the vertical translation. So this is an up and down translation, and you get a translation that moves horizontal, left or right. So horizontal translation. So again, you need to understand what a translation is, and that there are two types of translation. There's a vertical one where the graph literally moves up or down, or the horizontal one where the full graph moves either left or right. So let's talk about vertical translation, but particularly we're talking about one where the graph moves up. So a graph that moves up. So how would this look? So this, you'd be given an f of x, obviously, and how they're gonna represent it. They're gonna say that f of x is being added with a value. And in this case, I'm saying I'm using a q, and that q just represents a constant. It could be a 3, it could be a 4, it could be a 5. Point is, it's being added with that constant. So as long as that q value is a positive, then we know this as a vertical movement that moves the graph up, right? And maybe while we're still on the same topic, let me show you examples of how a graph could move up. So if I have an f of x, and this is my graph of f of x, then I tell you that f of x, or rather a new graph, which I'll call h of x. H of x is derived by you taking the f of x and you moving this guy 4 units up. So first of all, how do I find the h of x graph? I just take the h of x graph. Here, wherever I see f of x, I'm going to substitute this guy, right, for f of x. And so I'll have an x squared plus 3x minus a 2. But there's still this plus 4 that I need to still account for. And if you do your like terms there, you should see that the new graph is a plus 3x with the plus 2. So comparing this guy and this guy, those two equations are different. How? Because this guy was at -2 and this new one is now at +2. So it actually moved 4 units up. So that is a vertical movement that moves up, and this is how you're going to find the new graph. Then let's look at how a movement could be going down, and how do we find the new graph for that. All right, so now let's take a graph is moving down, that moves down. And so since this one is moving down, f of x will turn into an f of x minus a q. But I'll write it as a positive q plus q. And in brackets, I'm saying if that q is negative, then that's how you're going to get your downward movement. I hope that is making sense. So the f of x is being subtracted now with a certain value. So if that value of q is -3, the f of x will be moved 3 units down. If that value of q is -4, then the f of x will be moved 4 units down. But how do you find the new h of x graph? So let's say h of x is equal to f of x minus 3. Let's take a different graph for f of x this time. Let's take exponential. So there's our exponential, and I'm saying that this exponential is being affected by this translation here, which is 3 units down. So how do I do it? Again, in the place of f of x in my equation there, I substitute that left hand side, that right hand side I mean, and so it looks like this, and you're still gonna show your -3 there. And if you evaluate this and do your like terms, then the 4 and the 3 are going to subtract, and so the new graph looks like this. And there we go. Again, when you compare this guy and this guy, you should be able to see that, ooh, initially this was a 4 and this is a 3. So that have to have been a movement that moved it 3 units down. So I hope you can see, how do we find the new graph, which is h of x, and how do we describe the movement? I've been describing the movement to you throughout this video. So I hope that makes sense. That's translation. Then let's look at the other type of translation, and this is a horizontal translation. I'm going slowly through this because I want you guys to fully understand this. So what does a horizontal translation look like? So if I'm moving, if the graph moves to the left, how does that look like? So we'll be given an f of x, and the new graph would have a x there that is being added with a constant. So that's what moves the graph to the left. If you're adding to the x, so I'm not adding to the function, I'm adding to the particular x value. I need to go specifically to the x value, and to that guy I need to be adding this q value. So obviously a movement to the left, that's if q is positive. And again, let me show you an example. I can take different graphs. So f of x is, let's take a hyperbola, 3 over x minus 2 plus 3. That's our f of x. Then I say h of x is derived by you taking f of x and adding a 3 to it. So what would that h of x actually look like? So my h of x will be equal to, I need to write the f of x, and then wherever my x is, do you see where the x is? Wherever the x is, I'm going to go in its place, and I'm going to replace it with the x plus a 3. Another way to think about that is that wherever the x is, I'm going to add a 3 next to it. So this is my x plus a 3. I still have my -2 there, and I still have my +3 there. Then this you can do your like terms on, and when you do your like terms, the final equation will look like x plus 1 with the +3. So there we go. So this is how I take a graph that is the hyperbola, and how I take it through this translation there, which is, as we've discussed it up here, it's a movement to the left, and so this is how my new graph is going to look. So I hope that makes sense. What I really want to drive across is that you guys need to be able to take a f of x and find the new h of x. You should be able to do that. So I've shown you if a graph moves up. Let me show you actually if the graph moves to the left. Let me show you if the graph was moving to the right. How would that look? All right, so we've discussed that. The next one is if the graph moves to the right. So the key word here is right. So how would that look? We have a f of x, and that would have a f of x plus a q. We're going to write it as a plus a q, but what we need to understand is that q in this case is negative. So essentially I am subtracting to that x. And if you remember, positive takes it to the right, right? And then positive takes it to the left. It moves the graph to the left, but a negative moves the graph to the right. So how would I find h of x? So let's take another f of x, a different graph. Could even take a exponential. So there's my exponential graph, maybe with the +2 there, the exponent with the -3. Then I say h of x is f of x. Remember, what am I doing? I'm subtracting. So if I say -3, then how do I find my new h of x? This is how you find your new h of x. You write everything that you see there, but wherever you see x, you're either going to replace the whole x with x minus 3, or next to the x, you're going to subtract a 3. So there's my -3, and this is how it looks. And if you had to simplify that, we always need to simplify it, guys. We can't just leave it like that. So you have to simplify it. And if you do simplify it, -3 with the +2 gives me an x minus a 1, -3. And so this is my final equation. So I hope you're seeing it now. I've done a couple of examples where I'm showing you step by step how do you get the new graph, and I'm also explaining to you how would you describe that. So again, if you're given this graph here and then you're given this new h of x there, and if you look at those exponent guys and you compare those, you can see that initially it was a +2, now it's a -1. So what would have happened to it? I'm definitely subtracting the x by 3. And if I'm subtracting the x by 3, what does that mean? It means this is a graph that is moving to the right. I hope that is making sense, guys. All right, so we've done translation. Then let's do the other type of transformation, which is reflection. So before I start with reflection, what I really want everyone to understand is this idea, and it doesn't really take a lot to understand. This is my y-axis, and this is my x-axis, right? So if I had a point here, which is a 1 and a 2 for y, let's say that point is A. If I were to reflect this point about the y-axis, then my new point would form this side. And where would that point be? It would be right there, where x is now -1, but y is still 2. So what am I trying to show you? What is Mr. Malaji trying to get across with this example here? I'm trying to get across that if it's a y-axis reflection, what actually changes is not the y, but the coordinate of the x. That's the one that changes. Again, if it's a y-axis reflection, what changes is the coordinate of the x. So what does that tell me? it tells me that whenever I get a y-axis reflection, then the thingy that's going to change in my equation is the x coordinate, or rather the x value that you have in your equation. So let me put this away, and it's the same with the x-axis. Maybe before I put it away, let me talk about x-axis. If I was reflecting the same A about this x-axis, the x-axis line, then this new A would be forming down here. And what would have changed with the A, the x coordinate of the A would have stayed the same, but the y coordinate of that guy would have changed. So what I want you to really understand, guys, is that x-axis reflection changes the y coordinate. The y-axis reflection changes the x coordinate. It's always the inverse. If I'm talking about y-axis, I need to think about x coordinate changing. If I'm talking about x-axis, I need to think about the y coordinate change. So with that in mind, then it's quite easy to understand these translations, these transformations that I'm going to do. So again, if it's a y-axis reflection, the x will become negative. But since we're talking about graphs here, we're not talking about a point, we're talking about graphs. If you have an f of x like that, how would a y-axis reflection look like? Then I am actually coming into that x and I'm timesing that x by negative. So this whole idea of me going to the x and timesing it by negative is very foreign. It's very hard to understand, and it only helps if I give you an example. So let's take an example. I can even take what? A straight line. Let's switch it up. Let's take a straight line. That's my f of x. Then h of x is, you're told that this is the f of x that looks like that. So clearly the x is negative, so they're telling me that this was reflected about the y-axis. How do I find my new h of x? You just take your h of x, your f of x, and exactly where you see x, you're going to replace it with a negative x. So this is how it's going to look. It's a 2. The x got replaced by a negative x, and this is how it looks. So instead of changing a coordinate with the example that I was showing you, we're actually going to change the value of x. This is usually where you substitute your x. So it was a positive and now it's a negative. So how do you simplify that? So h of x will therefore be a negative 2x plus a 3. And this is how the new graph looks like. I hope that is making sense, guys. I'm spending a lot of time on this, and that is because I really want you guys to understand what I'm saying. So now let's move on to the other one. Just gonna erase that. You can pause the video if you want to see it. X-axis reflection. And with each one, you will see that I am showing you how it would look. So x-axis reflection, we've talked about this. The y will become negative. All right, so how does this look? Again, if you have a f of x like that, but this time remember that f of x represents the y. We don't want to write y, instead we write f of x, so that whole guy represents the y. So that's the guy that's going to be multiplied by negative. Take note, this is where the negative is multiplying, but for this case, the negative was multiplying the actual x. But in this case, the negative is applied to the whole function. So what does Mr. Malachi mean? Take f of x as being a parabola, a hyperbola, 2 over x minus 3 minus 3. That's my f of x. Then I tell you h of x is equal to the negative of f of x. So again, what am I doing to it? The fact that I'm timesing the whole f of x with a negative, the fact that there's a negative there, tells me that this is a x-axis reflection. How do I get the new h of x? H of x will therefore be equal to negative times the whole function. I'm going to use brackets right now, and that is because I want you to see what is this negative doing. It's timesing the first fraction to give me a negative 2. I'm just going to write it like this. You can write it like that. And it's timesing the next guy to give me a positive 3. So this is my new h of x. And there we go. I hope again you're seeing what I'm doing. All right. Then lastly, I've talked through the 4 important ones. There's one last one, which is this. I'll first talk about a shrink. So if you're shrinking something, you're squeezing it, you're making it smaller. And what would happen to the f of x in that case? So here you are multiplying the f of x with a fraction. So it will look like something like this, where you have f of x, and now f of x is being times by a fraction. Instead of writing an actual fraction there, I'll put a q there, where f of x is being times by a q, and this q is either a fraction, but to be specific, it's a fraction that is between less than 1, but it's greater than negative 1. That's the fraction I'm talking about. So if it's a fraction greater than 1, then that will not be a shrink. That will instead be an expansion, or rather it will be a growth. It will be stretching, right? Again, let me take an example. F of x is this graph here. Let me do a parabola. Maybe this guy, x plus 2 squared plus 5. We're not drawing these. Don't really need to even understand what the graph looks like. All we need to do is to be able to get the new h of x graph, which, like I said, I'm timesing it. So let's say it's times by a half. So it looks like that. Then how would this look? So h of x, the new graph will be a half times the whole bracket. So I want to indicate it, or rather times the whole function. And I want to indicate it with brackets because this half here would times that first bracket, giving me x plus 2 squared with the half in front. And it's going to times the 5, giving me a 5 over 2. So this is my new h of x graph. I hope that is making sense, guys. I hope you're seeing step by step what I'm actually doing. And towards the end of the video, I'm also gonna share, I'm gonna do an example where I put all these different transformations in one equation. All right, so that's a shrink. Then let's talk about a stretch. So stretch, you're also multiplying f of x, but now you're multiplying with a whole number. So again, f of x will look like that, but when it's changed, it's being multiplied by this q, but that q is particularly a whole number in this case. So what is the difference between a shrink and a stretch? Is the value of the q. If this q is greater than 1, or if this q is less than -1. If it's in one of those ranges, then it will definitely be a stretch. So I won't do an example like that because I think the shrinking one should have at least spoken to you about this. What I do want to do is I want to do maybe 2 or 3 examples where I'm showing you different guys, and what we need to find is the final equation. So there's f of x, and it's equal to a negative x plus 2 squared plus 5. All right, then A, find me h of x where f of x is being times by negative. So again, at this point, you should be able to see the fact that I'm timesing the whole f of x by negative. That means I am changing the y to be negative. And once I'm changing the y to be negative, that's an x-axis reflection. So again, just by looking at that guy, I can see that's already an x-axis reflection. But beside that, they're also putting a +3. And they want us to find the new graph of h of x. So h of x will look like this. F of x, I put a negative outside, and in this big brackets, I put what the function is. And then additionally, I put my +3 outside of the brackets. So do it like that. It's going to help you because this negative will times with that bracket, and it's going to times with the 5. And if that happens, we end up with a positive bracket with a -5, and this -5 is being added with a 3. And so my new h of x is x plus a 2 squared minus a 2. And if I were asked you to describe this, first of all, you would look at this guy. What is that guy saying to me? That guy is telling me that this is a x-axis reflection. I'm timesing the y, so this is an x-axis reflection. Then again, what else are you looking at? You're looking at this +3. So again, remember, if q is a positive and it's being added to the guy, then that would just be a vertical movement. I didn't have to write vertical movement. I could have just said 3 units up. It's a vertical movement that moves the graph 3 units up. So please don't say it moves it -2 units down, or rather 2 units down. And don't say it moves it 5 units up. No, the equation started with the +5. It started with this, and now we have this. So I'm comparing from a 5 to get to a -2. How did it happen? But here, 2 things happened in between that. So you can't just compare the 5 and the 2. You actually need to check this guy. What did they do initially? And yeah, with that guy, you should be able to see what happened there. All right, can pause the video, take it in. If you still don't get it, I will move on to the next question. So I'm taking the same f of x, which is a negative. Actually, let me switch it up. Let me take an exponential. 1/4 x plus a 2 minus a 3. All right. Then as part of this exponential, we're asked to find h of x, where f of x is being timesed. It is also being enlarged, and it is also being moved. All right, so just by looking at this guy, I don't need to have done calculations to see what is happening. So the fact that this guy is being times, the x is being times, already my brain is telling me that has to be a y-axis reflection, right? The fact that this guy is timesing the full function, that has to be a stretch, and that's a stretch by 2. And lastly, the fact that this guy is being added to the function, that has to be a movement that takes it 4 units up. But let me first find the equation and then I'll describe it. So how do we do this? I keep my 2 outside. I'm going to have my function in there. And wherever I see x, remember guys, wherever you see x, you replace it with a minus x. And then I still have my plus 4 there. So I can compute all of this. I just need to do a little bit of algebra. So what I'm going to do is I'm going to times this 2 in. So if I times it, I have a 4, open bracket, 1 over 4, the negative x plus 2 with a minus 6 with a plus 4. So let's do these. And so h of x is equal to 4, 1 over 4, minus x plus 2. And those, if they add, they just give you a negative 2. So you could leave it like this, but I don't like looking at it like that. What I like looking at it as is that x needs to always be positive. So what am I going to do there? I'm going to use this law that says a to the negative of x. I can rewrite this as 1 over a with a positive x. I hope you're seeing that law, guys. So that law says if the exponent is negative, it's an exponential law, you can just flip the guy and write it as a positive exponent. So that's what I'm going to do. But before I do that, I need to factor out a negative. So in that whole exponent, I first factor out a negative. And if I do that, this is now a minus 2 with a minus 2 there. And now this negative affects that fraction to make it a whole number. And if that happens, h of x is now a 4 outside, a 4 inside, and x minus 2 with a minus 2. And this is the way I like looking at it. And then again, you're asked to describe this. So I'm going to start with the x-axis, the y-axis reflection. So that's a y-axis reflection. And where is Mr. Malachi getting that from? The fact that the x is now negative. My brain needs to tell me the inverse. The y, it was reflected in the y-axis. The other thing that happened there, it was moved 4 units up. 4 units up. And what else happened there? It was stretched by 2. Stretched by a factor of 2. And there we go. So this is my new graph, and that's how you're gonna go about explaining it. I hope this makes sense. I hope this was fruitful and you learned something. Please make sure that you pause the video, you do more practice on this, and you totally understand this. On that note, that's it from my side. Bye.